Today, we are taking you inside one of the most ambitious engineering projects in modern India.
A project so enormous that builders had to break through a mountain, redirect a river,
reclaim unstable coastal land, and transform an entire landscape before a single passenger aircraft could take off.
This is the incredible story of Navi Mumbai International Airport.
And before we begin, make sure you subscribe to the channel and turn on notifications.
Because here, we reveal how the world's greatest cities, airports,
bridges, tunnels, and mega projects are actually built.
Now, let us begin. At first glance, the finished airport appears almost unreal.
From above, its three interconnected terminal volumes form a vast, balanced composition.
Inspired by the lotus, one of India's most recognizable cultural symbols.
Enormous metallic roof pedals flow across the terminal complex. Long concourses extend toward dozens of aircraft gates.
Two parallel runways stretch across the coastal plain, surrounded by taxiways, aprons, cargo facilities, maintenance hangars, transport links, drainage corridors, and a powerful air traffic control tower.
But this magnificent aviation hub did not begin with glass facades, golden roofs, or aircraft. It began with a landscape that seemed almost impossible to build on. The site near Ulwe was dominated by difficult natural conditions. There were hills rising above the planned airfield, soft coastal soil beneath the future runways,
wetlands vulnerable to flooding, and a river crossing directly through the airport development zone.
Before construction teams could build upward, they first had to completely reshape the ground beneath the airport. The first great obstacle was the hill. A runway requires an extremely long, stable, and accurately graded surface.
Even minor changes in elevation can affect drainage, pavement performance, and aircraft safety. The existing rock mass therefore had to be surveyed, drilled, excavated, and broken down, and removed in carefully controlled stages.
Drilling rigs, bulldozers, crushers, and enormous fleets of haul trucks worked across the site. The hill was not simply destroyed in one dramatic movement. It was gradually cut into engineered benches,
With each layer inspected before excavation continued deeper.
Usable rock was processed into graded aggregate. Instead of treating the mountain only as an obstacle,
Engineers transformed part of it into construction material for the airport itself.
and enormous fleets of haul trucks worked across the site.
Drainage foundations, replacement fill, runway subgrade, supporting layers. But removing the hill solved only one part of the problem. Blocking it without a carefully designed alternative could increase flooding across the surrounding lowland.
Damage nearby communities and threaten airflow during the monsoon season.
So engineers had to give the river a name. Before excavation began, hydrological teams studied the river's depth, bank geometry, flow direction, flood behavior, and surrounding wetland levels.
Surveyors marked a new diversion corridor, while geotechnical crews investigated the soft ground beneath the proposed channel.
Temporary access roads were built across the saturated floodplain. Environmental barriers were installed
to control sediment. Excavators then began shaping the new river corridor in short, isolated sections.
while the original river continued flowing beside them. Geotextile separation lines were installed.
Graded stone created a stable foundation.
Larger interlocking rods protected the channel inlet and side slopes against erosion.
The new channel was extended reach by reach until its inlet and outlet were structurally complete.
Yet the river could not be redirected immediately. The diversion channel first had to be inspected, wetted, and tested. Water was gradually introduced from the downstream end to identify unstable banks.
Display stones, leakage, or erosion before the active river entered the system. Only after the entire corridor passed inspection did excavators slowly open the upstream connection.
At first, only a small portion of the river entered the new channel.
The opening was gradually widened, allowing more water to follow the engineered route. Eventually, the main flow moved completely through the diversion corridor.
While the original channel became a quiet, isolated one, the river had been successfully bent around the future airport. But another major challenge remained beneath the surface. The abandoned channel and surrounding coastal riverbank contain deep layers of saturated mud, weak clay, organic deposits, and unstable alluvial soil. These materials could not safely support aircraft weighing hundreds of tons. The old riverbed was isolated and dewatered. Pumps lowered the remaining water through sediment control systems. Once the channel bottom became visible, engineers mapped the weak deposits and divided the area into controlled excavation panels. Long-reach excavators removed the unsuitable material strip by strip. The exposed formation was covered with heavy-duty geotextile and geogrid reinforcement. Drainage laterals were installed beneath clean aggregate blankets. Then the enormous filling operation began. Crushed rock produced from the original hill was delivered in controlled layers. Bulldozers sprayed each layer. Water trucks adjusted moisture. Heavy rollers compacted the material again and again. After every major layer, surveyors checked the elevation. Geotechnical teams monitored settlement. Loaded vehicles proof-rolled the surface to reveal hidden weak zones. Where movement appeared, the defective area was excavated, rebuilt, and tested again. The